Hello everyone, welcome back to the another session on quantum computing. In this video, I am going to discuss about the quantum measurements. Before discussing about the quantum measurements, uh, first 1 or 2 minutes I will discuss about the meaning of measurement related to the classical. So classical measurement is the process of observing or measuring a physical quantity that already has a definite value before the measurement. For example, height of a person. For example, just I'm taking height of a person. I just take as an example of mine. For example, my height is like 180 centimeter. It's already exists. My height is already exists. If I want to know the exact height, I use the scale or I use a tape and I measure it. It will give the answer like 180 centimeter. Similarly, if I want to check the temperature of a particular day on particular time, so for example, temperature is measured like 35 degrees centigrade. Here I measure the temperature of 35 degrees for a particular place on particular time because it already showing or already the heat is exists like a 35 degrees centigrade. That parameter I am measuring. So here the classical measurement is nothing but it's just an observing or measuring a physical quantity that already has a definite value. That is, definite state is exist. Definite state exists. That part we are measuring. Either it might be temperature, or it might be height, or it might be color, or whatever it is already existing. We are just measuring it. And measurement doesn't change the system. For example, if you measure my height, is there any change in the height? Similarly, every measurement gives the same value. Every measurement gives the same value. This is related to the classical measurement. Because the classical measurement is nothing but just measuring the existing parameter, that is definite parameter which already exists. So finally, the classical physics relate to the measurement point of view. It reveals a property that already exists. The act of measurement, whatever the measurement on a particular system, it doesn't change the system. But in case of quantum physics or the quantum mechanics or the quantum measurement point of view, as we know that the quantum measurement is nothing but the process of obtaining information from the quantum system. I just imagine a quantum system which has the information is available in the qubit or electrons or the photons or the spin or whatever it is. I just take it as like a quantum system which is having or which stores the information in terms of bits. Alpha state 0, beta state 1. Here alpha beta are the complex parameters and state 0 and state 1 are the base states. See here, this is the quantum system. It is information is stored. We want to take the information or we want to measure the quantum system which is having information in terms of qubit. Before measurement, the system information is available in the superposition of different states. Superposition of different state, because we can't expect the answer. It might be 0 state or it might be 1 state because it's a superposition of all the available base states. Once you measure it, once the system is measured, then after measurement, the state nowhere is in the superposition. The system need to be show one definite outcome. One definite outcome. It might be 0 or it might be 1. Before measurement, it is in the superposition state. After measurement, it should have one definite outcome. That is possible. Measurement doesn't change or doesn't just observe the system. It also changes. In discussion of classical, it just observe the system and it will give the value. It never change the system. But in case of the quantum measurement, initially the state psi. Once you apply the measurement, then it will give the definite outcome. In addition, here it is in the superposition, but this system, this superposition state is completely collapsed into one definite value. So that is nothing but the quantum measurement. Quantum measurement changes the system, it in addition to the observing the parameter. Classical physics or the classical measurement only check the value, but quantum measurement the force the system to choose a particular value, and it also change the quantum system. As discussed, the qubit is available in this superposition form. For example, I just take it as like a single qubit. That's what I just take it as two states, the combination of two states, which is nothing but superposition. It is represented as qubit. What will happen because of the effect of measurement? Because of the on this particular state, because of the measurement, what changes we can observe? See here, first one, superposition destroyed. There is no superposition. After the measurement, the state is nowhere in the like in the initial state. This total superposition is destroyed. The quantum state collapse into one definite state, and obviously the classical result is obtained. After measurement, classical result is obtained. Either it is possible in the either state 0 or state 1 is the end result, but not this superposition. So how it can measure? On what basis it choose the state final end result? It may choose the result either 0 or 1, right? How it can be possible? It just check the based on the probability functions. So the state psi is having like a alpha 0 state plus beta state 1, and where alpha beta are the probability amplitudes and alpha square is the probability of state 0 and beta square is the probability of state 1, and the condition is alpha square plus beta square equivalents to 1. Based on the probabilities of different state, it will choose the one particular value as end result. In addition, one more concept, measurement base. For example, in the Bloch sphere, while explaining the Bloch sphere concept, each and every qubit position, like a single qubit position, is represented as a point on the sphere. This is the origin point. We just take it as this one is the x-axis and this is take it as like y-axis, and this we represent it as z-axis. And when we are taking it as a z-axis point, north pole is represented as 0 position and south pole is represented as base state 1 or the base 1. Similarly, x point of view, it is a state plus, and another state minus. Here the plus and minus is related to the 1 by root 2 of state 0 plus state 1. Similarly here 1 by root 2 state 0 minus state 1. Similarly, in case of y, we just represented as state I plus, and here it is state, which is nothing but 1 by root 2 state 0 plus I into state 1 by, root 2, it already exists, right? State 0 plus I into state 1 is related to the y base. Here when we choose in the z base, in the measurement point of view, if you are choosing the z basis, the end result might be a 0 state or 1 state. If you are choosing the x base, then obviously the end result might be plus state or minus state. Here the plus is nothing but state 0, superposition of state 0 and 1, 50-50 probabilities. State 0 plus state I by root 2. Similarly, minus is nothing but state 0 minus state 1 by root 2. Whereas in case of z basis, state 0, state 1. But how we will get the end result by using the x basis? Always gives the result like either plus or minus. If you want, again it is in the superposition principle, right? If you want to get the end result like a classical like, we need to operate this particular state by using the Hadamard gate. So Hadamard gate of on plus is gives the 0 state. Hadamard gate operate on the state minus relate to the x base, it will give the end result as 1. So again we need to some operators to get the answer. That is the quantum measurement not only gives the classical values always, it also gives the superposition answers also. To understand the quantum measurement of a single qubit in a clear manner, I just take it as an example relate to the single qubit, that I take it as like 0 psi equivalents to state psi relate to the 0 by root 2 plus state 1 by root 2. Here just analogy, it is similar to the alpha state 0 plus beta state 1. Here the alpha beta are the probability amplitude. Similarly here also alpha is related to the 1 by root 2 and beta is related to the 1 by root 2. As mentioned, like a probability of state 0 is equivalent to alpha square, that is nothing but 1 by 2, which is equivalent to 50%. Similarly, state 1 is also 1 by 2. This is also 50%. So first, whatever the chosen, the system is in the superposition. It might be available in the state 0 or 1. We chosen the base states like z basis. The end result might be in the state like a 0 or 1. And then we measure the probabilities 50-50. When the measurement actually done, the qubit gives the one definite value. It might be either 0 state or 1 state. Suppose if the end result is 0 state, then finally initial state is in the superposition. It collapses into the 0 state. That is, before measurement it is in the state, after measurement it is in the state 0. Here it is in the superposition. After measurement on this particular state, it gives the definite value. And then repeat the measurement immediately. Repeat the measurement. It gives the always gives the value of state 0. If we immediately measure the qubit again in the same base, the result will be 0 with 100 probability because the state is already collapsed. The state is collapsed, only the qubit is available in the 0 state. So therefore, the final one, note, before quantum measurement, it is in the superposition. Measurement, it might be random, but it is depends on the probabilities based, that is probabilistic. After measurement, definite value like classical output, and repeat the measurement, it gives the same value. It gives the same value as completely collapsed. So this is the concept related to the quantum measurement. Understanding the quantum measurement is crucial because we want to get the data from the quantum system. So when we are getting the data or the information from the quantum system, we should understand the how we can extract the data from the quantum system by using the different measurements. Measurements are nothing but it's like a parameters, operators. Thank you.